Design and Fabrication of Composite Prototypes, a 5-day interactive multimedia seminar by Mike Arnold. Mike Arnold was an industrial and commercial filmmaker until 1978, when he was drawn to the Mojave Desert to study gliders, and the Rutan designed Very Easy Home Built. He has worked in prototype and composite design and fabrication ever since, on projects ranging from canoes to NASA hypersonic experimental aircraft. In 1992, Mike's AR-5 design set a new world speed record, and he was awarded the FAI's coveted Louis Blériot Medal the following year. Mike's broad experience and natural exuberance for his subject have combined to produce an exciting and unique 5-day interactive multimedia seminar. The seminars kick off Monday morning with a general discussion of weight and drag reductions achievable with composite construction, and how to apply them to particular projects. In this case, it happens to be a battery-powered car, but the course can just as easily be tailored to any object that can be made of composites. After some aerodynamic examples and explanations in the parking lot, Mike has worked on several concept cars for major auto companies. It's back to the blackboard to design an example car. Not a very stylish one, but good for examining standard structural elements. These parts, normally made of stamped, forged, or welded metal, will all be replaced with composite materials. Then it's time for a video overview of various prototype construction methods, followed by detailed design of a typical frame member. We've isolated a section of the frame and A pillar and decided to build it. And that ends day one. Tuesday morning begins in the classroom with a short explanation of the simple engineering used to determine the amount of material necessary to provide proper strength. Then it's out to the shop to round up pieces and forms for the construction of the A pillar and frame member, and a sample door panel. Then the fun begins. Mike's philosophy has always been to encourage as much hands-on experience as possible, so everyone gets a job. These relatively inexpensive and commonplace materials are ideally suited for prototype or one-off applications. Plastic foam is easy to shape and quick to assemble with 5-minute epoxy.
So, let me get started here and then turn this over to whoever was doing it.
True to his philosophy, Mike is always ready to share the carving fun. These practical and effective carving techniques are quickly learned, and progress on the frame member form is rapid. The two halves of the A pillar core, in the foreground, are ready to be bonded together with epoxy, while the team on the frame member prepares it to be fiberglass the next day by covering it with duct tape. The tape is necessary so the styrofoam form can be released and removed after the layup is cured. Meanwhile, the door panel is carved and prepared for fiberglassing the next day. Wednesday begins with a video and detailed discussion of mold making. Then it's back to the shop to lay up some actual parts. This is epoxy and standard fiberglass, although carbon fiber and Kevlar use the same techniques. Mike has developed this method of pre-wetting multiple plies between plastic, which makes it possible to prepare thick laminates quickly for a process called drape forming, which allows rapid and easy fabrication of large, complex parts. This frame member and a portion of the floorboard will cure here overnight. After the door is wet out with traditional bucket and brush, a squeegee is used to remove excess resin. Points are awarded for style. Also on Wednesday, we make a quick mold of a strut fairing.
Oh, gee. Yeah,
And we learn standard waxing and mold releasing techniques so we can reproduce a fiberglass part from the mold. And that finishes the day. On Thursday, the styrofoam plug is removed from the frame member. And the backside of the door is laid out and trimmed. The A pillar is bonded to the frame member and glassed. And the inside of the door is coated with microspheres and epoxy. And it's glassed. And that ends Thursday. Friday, the part laid up last night is removed from our mold, and examination and testing of our work begins. This is the most rewarding and informative part of the course, because we get to see how light and strong these pieces are, in very real terms.
Whoa! So you're going to beat that thing up, huh? I think I'm going to beat you up. Come on now, we need that off of there.
Although this looks like frivolous fun, it's actually quite serious.
Oh, I know this is going to... What's wrong with this picture, man?
We get to learn how to detect and repair damage.
Compression failure.
Right there. Little
Now how do we fix it?
You grind it out
And we discover the limits of 30,000ths of an inch of fiberglass.
There we go.
Got serious there.
Now you punch
Don't lose the board, Jim.
It's pretty tough. Next, Mike demonstrates finishing techniques with body filler, showing how to spread it evenly and quickly, and how to take advantage of its brief semi-soft state during the cure by using a cheese cutter to remove the high spots while it's easy. A little sanding then finishes the job. After a brief summation and a question and answer period, it's time for handshakes and diplomas. This course was presented to instructors at the Sacramento City College Department of Aeronautics, but it can just as easily take place at your facility. If you're interested, please give us a call.
We did it.
Compound curve.
How hard?
No, we
Compound curve.
We hand carved it.
We carved it.